Hey everyone, I want to cover 6, 7, and 8 in this one. Hopefully everything stays on the screen this time. All right, let's start with the basics. Looking at the periodic table, there's a reason why we colored this. Because we can separate the periodic table of elements into 3 categories. We have our metals, we have our metalloids, and we have our non-metals. Now, if we recall, elements who share the same group share similar properties. You remember back in like the first thing we did, we drew little alien creatures, or we sorted little alien creatures, and the alien creatures that had like the same belly design and the same facial shape, we stacked them on top of each other, right? So like, for example, copper, gold, and silver, copper, silver, and gold, they share similar properties because they're in the same group / family. Now, why am I talking about this? Is we need to talk about, in general, the properties that these things have. So when we look at question number 6, we have separated these into 3 groups. So the 118 elements on the periodic table into metals, metalloids, and non-metals. A reminder, the metalloids touch the staircase. What makes them metalloids? Well, they're similar. They have similar properties to metals and non-metals. We talked about silicon in a lab that we did. Silicon, you noticed, had the malleability of a non-metal, but it had the conductivity of a metal. These things, metalloids, these things share properties of both metals and non-metals. Metals have similar properties, non-metals have similar properties, and we'll go over that here shortly. Think back to your lab that we did in class. Now, metals, these tend to be, well, first off, here's some vocab. Luster talks about the way light interacts with it. A fancy way to say it is it shiny or dull? So metals, for example, would be shiny, while non-metals would be dull. And metalloids, like I said, could have properties of both. They could be either or. So I like to write either or. Oh, I spelled either wrong. Either or, okay. Meaning that some metalloids are shiny. Think about the silicon that we used in class, while some metalloids could be very dull. Conductivity, metals. And what does conductivity mean? The ability to conduct heat or electricity. Metals conduct heat. So yes, heat and electricity. Guess what? Metals and non-metals are opposite. So are the non-metals conductive? The answer is no. Now, metalloids, they're what we like to call semiconductors, because guess what? They conduct electricity, sort of. Semiconductors, easy. And then malleability, that's like, can it be bent or shaped or pounded into sheets? Metals can. So yes, most metals are malleable, the majority of them. Guess what? Non-metals are the opposite of malleable, which is the word brittle. And I used that cookie analogy in a video way back. And so metalloids, guess what? Either or. I spelled either wrong again. I'm really struggling here. Okay, cool. So again, a reminder, when we look at the periodic table, metals on the left of the staircase, non-metals on the right. You should have took that note. Metalloids are very kind of in between, and they would share properties of both metals and non-metals. They're very special. So when we look at this chart for number 7, it says which element listed in the chart below is a non-metal. Well, I'm looking for an element that has these characteristics or these properties. So I'm looking here, I see titanium, selenium, potassium, polonium. Well, I could do like the painstakingly long process and sit here and try to find all these elements. But let's just read about their properties. So I'm looking for something that's dull, is a poor conductor, and is brittle. That was easy. Okay, great. The answer is selenium. Give me 2 reasons. Well, here are the 3. 1, 2, and 3, because I know that metals tend to have a high luster. They tend to be very malleable. And metalloids, are kind of in between. Now, if I was really looking at this, look at polonium. It says, can somewhat be shaped into seeds. Is a semiconductor, sort of metallic. This is a metalloid. Potassium and titanium are metals, while selenium is a non-metal. And then lastly, same type of question, number 8. Which element is least likely to conduct heat or electricity? Use your periodic table. Well, pretty darn easy. Left of the staircase, metals. Right of the staircase, non-metals. What's my one element right here that's right of the staircase? That's oxygen. Most oxygen can be found in gases. It's not very conductive. I hope that was helpful. Maybe you watched.
See ya.